Hi. We're going to continue discussing sampling distributions. And in addition to discussing sampling distributions generally, we're going to discuss the use of a specific type of sampling distribution, the little t, probability distribution. But first, before we go there, I want to introduce you to another statistic, a new statistic, although it might not be new if you have indeed read Chapter 7 in SPATS. Here's the new statistic. The new statistic is referred to as the standard error. Not the standard deviation, but the standard error. The standard error is yet another way that we can describe the amount of variation that a sample contains. Now, you've already dealt with, so in a sense, the standard error is yet another measure of dispersion. You've already dealt with several measures of dispersion. All right. Truth be told, you've dealt with a handful of them. First, the range is a measure of dispersion. All right, just simply the highest and the lowest scores. The interquartile range is yet another measure of dispersion. The variance is a measure of dispersion, and in weeks past you've dealt with the variance. The square root of the variance is the standard deviation. You've dealt with the standard deviation quite a bit. Last week, you dealt with the z-table, and you used z-scores in order to navigate the z-table, the normal probability distribution. And you also, or at least I tried to really emphasize that z-scores are units of standard deviation. I'm going to say that again. Z-scores represent units of standard deviation. All right, so all those are measures of dispersion: range, interquartile range, variance, standard deviation. The standard error is another measure of dispersion. So as I mentioned a couple minutes ago, the standard error is another way, another statistic, another number that we can use to describe a group of scores, a sample, regarding how spread out those scores are. Now, this exhibit is on a Blackboard as well, so if you don't have it, you might want to go ahead and get it. It's relatively straightforward, pretty simple. The standard error for a sample. If we wanted to find the standard error for a sample, the first thing we should probably keep in mind is what symbol represents the standard error, and that symbol is right there. That's a lowercase s sub x bar. Lowercase s sub x bar. This whole, where'd my pen go? This whole symbol together, that's one symbol, even though there's at least two parts, and three if you count the bar. But that symbol together, lowercase s sub x bar, that is the symbol that we use to denote the standard error for a sample. Lowercase s sub x bar. How do you calculate the standard error? Well, that's on this page too. The formula that you would use for the standard error is relatively straightforward, and that formula is the standard deviation, S with a hat over it, although I prefer that we refer to this symbol as the standard deviation divided by the square root of n, where n is simply the number of cases involved in our analysis. So if you wanted to find, or if you needed to calculate the standard error for a sample, you would need to know the standard deviation. And then once you have the standard deviation, or if you were given the standard deviation, what you would need to do is take the standard deviation and divide it by the square root of n, and that gives you the standard error. Now, that's a new statistic, or at least it's new in terms of us talking about statistics. And so I wanted to also introduce this exhibit, likewise on Blackboard, called samples and populations, or statistics and parameters. And I just want to remind you of what this symbol here means. That symbol right here. In fact, I'll circle it on my drawing. That symbol means to approximate or to estimate. To approximate or to estimate. And this drawing, although it's relatively simplistic, does have some logic behind it. Here you have a column that I'm calling samples, and here a column that I'm calling populations. The reason there's an arrow leading from populations to samples is because that's where samples come from. Samples come from populations. We sample from populations. Rarely are we ever able to study all of something for any number of reasons that we've already covered. So samples come from populations. In addition, once we have a sample, we are generating any sort of summary numbers that we derive from the sample are considered statistics. Okay? So statistics come from samples, just like samples come from populations. Populations give us samples, samples give us statistics. Now, we use statistics in order to estimate or approximate parameters. Parameters, oops, and I forgot an arrow. Parameters come from populations. So if we actually had a population, very rare conditions indeed, but if we actually had a population and we were deriving summary numbers like means and standard deviations and variances and all that, we would be generating parameters. But we rarely have parameters because and the reason we rarely have parameters is because we rarely have populations. Instead, we use samples to estimate, right? So we have samples which came from populations, statistics come from samples, samples are estimates of parameters. And in fact, I may have mentioned this in a previous YouTube clip, so if I have, I apologize for the repetition. Although given this is an online class, I don't see a whole lot wrong with repetition. But there are some journals in the social sciences that don't even use the word statistics. That word doesn't even exist. Instead, they use the word estimates because that's really what statistics are. Statistics are estimates of parameters. We use statistics to estimate what we can't measure directly. We can measure samples directly. We use samples in order to estimate things about populations. Now, you've been introduced to a lot of statistics so far. The mean is an estimate of mu, right? The mean, arithmetic average for a sample. Mu, arithmetic average for a population. We use the mean to estimate mu. We use the variance to estimate the population variance. We use the standard deviation to estimate the population standard deviation. And guess what? We use the standard error, lowercase s, sub x bar. We use the standard error to estimate the standard error of a population. So more often than not, we're using samples, which means we're deriving statistics, which means we are using estimates. And the most recent estimate statistic that you've been introduced to is the standard error.